I'm here to officially welcome you to this great webinar that we have today. The title is Unmasking a VS Code Supply Chain Attack. So we're going to get into some really good conversations today about how RL researchers were able to discover this. But before we do that, I'd love to go ahead and introduce who we have today. So I'm going to go ahead and introduce myself. My name is Carolyn Van Arsdale. I manage content here at ReversingLabs, and I'm really pleased to have two very skilled threat researchers with me today to talk about this compromise. And I'm going to go ahead and have them introduce themselves. So Petar, can you go ahead and introduce yourself for everybody?
Hello, my name is Petar Kirchner. I've been with ReversingLabs for a little over 2 years now, and I work as a threat researcher. Basically, my task consists of monitoring repositories and writing various indicators for improving our threat hunting systems.
Thank you. Carlo, what about you?
Hi, I'm Carlo. I worked more than 6 years here at ReversingLabs. More or less do similar things like Petar on a daily basis, and we are threat hunting and writing research blogs for the community to show what we found.
Thank you. Awesome. Yeah, so we're going to get into some great chats today. So just to give you all an overview of what we're going to be talking about, we are talking about the compromise of a legitimate VS Code extension that our researchers, Carlo and Petar, discovered a couple of weeks ago. But before we get into the compromise, we're going to be just giving some background on what VS Code is, why it's essential for developers, and then I'm going to have our talented researchers take it away and just explain what happened with this compromise, how ReversingLabs was able to catch it, the consequences of this compromise, and what lessons we can take away from it. And then at the very end, we're actually going to show you a free resource that software developers and the security community can use to vet VS Code packages for anything malicious that they need to be concerned about. So let's get started just with some background here. So before we dive into the details, Carlo, Petar, I would love to hear just in your own words what the VS Code marketplace is and how extensions work and how this platform and these pieces of software are specifically important for software development and for developers.
Yeah, so basically the Visual Studio Marketplace is a place where developers and organizations can upload their own custom VS Code extension. And an extension is basically, as the name implies, it extends the functionality of the vanilla VS Code editor. So for example, if you use a specific programming language or a specific technology and you want to make your life easier, you would install an extension that does a certain thing to help improve your workflow. Basically, VS Code extensions are similar to NPM modules in a manner that their file structure is the same. So basically, you have a package.json, which is a manifest file which tells you, okay, here is the entry point of this file, here is the dependency that this file uses, and a list of files that are included in the package.
So would you
That's
say,
basically the nutshell.
Gotcha. Sorry to interrupt you. I was just curious. So would you say that when we think about, oftentimes you all, the ReversingLabs threat research team, will discover open source software supply chain attacks on platforms like NPM. Would you say that these compromises on, NPM or PyPI are similar to compromises that we see on VS Code? Not just for this specific compromise we're talking about today, but in general?
Yeah, in general, the method of attacks are very similar from between these different repositories. So yeah, I would say they are pretty much similar. In most cases, what happens is there are new packages or new modules being published, new extensions being published, and they are malicious straight away from the very first version.
It's just the concept of extensions and package repositories is, while it is almost the same, the subtle difference is that when you install VS Code extensions, you are trying to extend functionality of your IDE code editor. And when you install packages from NPM and PyPI, they are mostly aimed at implementing some functionality in your code base of the project. So just a subtle conceptual difference. So here you are trying to make your tool be better, and in NPM, standard NPM and PyPI packages, you are trying to quickly implement some functionality, so you don't need to implement it in your code.
Gotcha. Thank you. Yeah, that makes sense, and that brings us, I think, to our next slide, where we can kind of get into more specifically this compromise, which was of a legitimate extension on VS Code called ETHcode. So let's just go over the basics here. Petar, Carlo, can you just kind of walk us through what we need to know about this extension?
This extension, the ETHcode, was developed by Seven Finney. It is a GitHub organization, and it's the first version was published in 2022. It had about 6,000 installs before we detected it, and its primary usage was to streamline the development of smart contracts. Yeah, it was basically updated monthly for years until this compromise, when it was where it had like a 6-month gap between the compromise version and the legit version.
Is that normal typically for VS Code extensions for their maintainers to, take like a 6-month gap, especially after it was updated monthly?
Well, I'd say it depends from extension to extension. Like if there is nothing new to add, or if, let's say, an extension is considered finished, then I guess it's okay to say, yeah, it's okay for that gap to be that long. But also, if you do see a gap for 6 months or above, where the new version is just recently been introduced, that does raise some eyebrows. Like, why was it not maintained each month like it was used to be?
Understood. I think we can go to the next slide. Thank you. So now we can really just get into what exactly happened here. Looks like we might, oh, never mind. I thought we had a question. I'm going to keep going. Just a reminder, if you do have a question, please just go ahead and use the Q&A feature, but I'll also keep an eye on the chat if anything comes through. But let's get into the anatomy of the compromise here, and all the different attack steps and how this happened. So do you all want to walk us through here these steps?
Sure. So there was a GitHub account that opened a pull request for this extension, and that extension was pretending to be a how do you say? It was basically pretending to help the developers, introducing new stuff, cleaning up some stuff, all under the false pretenses to just sneakily introduce the 2 lines of malicious code that actually compromised this whole extension. So when this pull request was opened, the reviewers, the maintainers, actually Seven Finney, reviewed this package, and they found nothing suspicious here. They just requested some minor improvements to be made, and that's what the tracked actor did. But secretly, let's say behind the lines, the tracked actor added 2 not really noticeable lines of code that compromise this whole extension. So amongst these 4,000 lines of code, there are 2 lines of code that added a dependency, which was named similarly to an already used dependency. So an already used dependency name was basic Ethereum, and the malicious one was named Ethereum utils. And what this malicious dependency does is, firstly, it was very obfuscated by an online tool called JavaScript obfuscator, and we had to deobfuscate it. And we found this piece of code that is on the screen right now. It basically downloaded a batch file, which was then subsequently executed. And this batch file was also very obfuscated, and we actually had to write a deobfuscator for it. And at the end of its whole process, after we decoded it and decrypted it, it would drop a quasi-rat malware.
So if we can just go back one slide, definitely want to get back to those 2 lines of code that really made the difference here. But I definitely want to go back to the fact that, the maintainers, 7Finny, they did review this pull request and they didn't actually find anything malicious in the pull request. And then also, I think it's worth highlighting too, and Petar, maybe, and Carla, you can comment on this, but there is, a GitHub Copilot AI feature that did, scan the pull request, and that did not find anything malicious as well. So I'm curious, how could this have happened in terms of the maintainers missing this and also the AI missing this?
Yeah, well, that can be explained. So firstly, the AI reviewer, the GitHub Copilot, it reviewed the changes, made a summary of all the changes so that it's easier to review, and just pasted it as a comment. But the final decider of what gets into the code base and what doesn't is not the AI. It is the maintainers, the users of the 7Finny organization, and they decide what gets in. Why this went under the radar is probably because there was nothing actually malicious in this code. The only 2, let's say, weak points that were introduced was this dependency and the usage of this dependency. So when they read the code, they did not think to find anything malicious. But when we scanned the package, the whole VS Code extension package, we found this obfuscated malicious code just because whenever a VS Code extension gets packaged, it downloads all the dependencies and neatly packages them in one unit where every code is located in that package.
Understood. Thank you. We can go forward a slide. So I do want to get into just what the real impact is for those who were using the extension or the specific malicious version of the extension. In particular, talking about, the Ethereum utils dependency, but then also QSAR-rat, which I think it's pretty interesting. Just doing some own digging myself, I saw that CISA, the Cybersecurity and Infrastructure Security Agency here in the US, has been talking about this specific remote access Trojan rat, for several years. But how does that play into now, and what impact do these 2 lines of code really have on developers?
Well, the quasi-rat is, I think it's a source available remote access Trojan that has its code, I think, online on GitHub. The real impact of this infection, we don't know. It had about 6,000 user installs, and VS Code extensions get updated automatically unless you manually go into settings and change that. So we can assume that maybe half of those.
Sorry, Peter. At each startup of Visual Studio, just to be clear, whenever you start whenever you start your Visual Studio code, editor extensions from your project get updated. So that's
exactly.
Not only when you publish your project, but each time you start your IDE.
Yeah, so it's safe to assume that some people got affected, and basically they now have a remote access Trojan on their computers that can monitor anything they do.
Understood. I think we can go to the next slide.
That's
So
perhaps, if I can once again emphasize the main difference between standard compromises with NPM and VS Code IDE is the fact that these extensions, if you don't specifically turn off auto updating, get updated at each start of Visual Studio Code. So that's an important thing. When you get compromised with an NPM package as a dependency, it's not that serious if you didn't do install packaging or something like that. If you do some coding and you have it as dependency but didn't do anything else, you won't be affected if you don't install a package. But here, just turning up your Visual Studio IDE gets triggering the installation of a new version of the extension. So that's an important thing to mention to get clear vision how impactful this can be and how.
we actually do have a question that I'll go ahead and share right now from Chris here. What about virtualized environments? You can do the install, but in theory, it's in virtualized environment. Would this have impacted this type of dev style?
Well, virtual environments are, I think, definitely safer to use, but it all depends what is on your virtual machine. Because if you use a VM for developing, that means that inside your VM you have Visual Studio Code. That means you probably do have some sensitive projects on that same machine. If that machine gets compromised, then by extension your files on that machine are also compromised. But it's definitely better than having your main machine get compromised, I guess.
Yeah, but again, this extension is designed for blockchain development and similar stuff. So it's quite possible that you will have secrets or tokens or private keys entered into that virtual environment at some moment during your development. So it's again, as Petar said, like better than having it run on your development environment that is not virtualized, but still prone to compromise of some degree.
Wonderful. Thank you both. Thanks for the great question. Please keep the questions coming. The chat is fine or the Q&A feature. So why don't we talk a bit about now regarding what exactly caught this compromise, how you all did it. So there were 2 red flags. Do you all want to walk us through what happened here?
The first red flag was ReversingLabs Spectre Assure predictive threat hunting models. Basically, it detected that this extension now has files with similar behaviors that were found in some NPM packages. That was the first red flag. And the second red flag was the differential analysis of the previous uncompromised version with the new compromised version, in which we see that basically we detected the presence of files with obfuscated software of components in this newer compromised version. That were the 2 main flags that caught it.
Understood. So can you, either of you talk a bit to, like the predictive threat hunting models that ReversingLabs uses? How are these models created? And then also to what behaviors are we really looking for when we see that RL Spectre Assure is flagging malicious components or anything that we should be wary of?
Carlo, can you take this over,
Yeah,
please?
about predictive threat hunting models. So basically, these are ML models that are developed in-house and not like LLMs, but in-house developed on specific training sets and based on set of features like any ML detection models is developed. It is the main advantage compared to, I don't know, using LLMs for security analysis of packages, is that these models are trained on a specific set of data, and they are constantly updated with our threat intelligence and everything we find on our daily basis threat hunting. So it's an iterative process. These threat hunting models get constantly updated and improved based on threats observed in public source repositories. So one of the reasons why we do threat hunting in open source package repositories is to stay up to date with techniques that malicious actors use in the wild. And when we observe such techniques, we try to improve our behavior indicators for our solution. And based on those behavior indicators, ML models get improved also. And the second question you had, Carolyn, was?
Yeah, just wanted to talk about specifically, like in the screenshot here, when we look at, the certain issues detected.
Yeah.
I think you
Okay.
pretty much nailed it, but yeah,
Yeah, but
you wanna go ahead.
the second thing to note about the product is differential analysis, concept of differential analysis. What you basically do, you compare two release artifacts for two versions, for example, 1.0 and 2.0, and you look at the behavior differences on a file level between the same files in the two versions and see what new behavior has been introduced in the newer version, and look at the set of behaviors and think if those are the behaviors that you designed for the product and that you wanted to implement in the product, and are those expected behaviors, and is it safe to serve to have them in the release artifact which gets distributed to your clients. So behavior differential analysis is a powerful tool for spotting behavior changes introduced between versions. So it's something that can help you distinct the new behavior from the general behaviors found in some version of the package. So you just want to focus on what changed since the last time, what behaviors have been introduced, and do these behaviors fall into malicious type of activity.
And this is really the technology that you all use to really verify and confirm, all the other compromises that you all discover, which if you're curious about, other discoveries Carlo, Pitar, and the rest of the team has made, you can go onto our website and check those out. But yeah, just to confirm, Carlo, it's really looking, I think the behaviors are a huge piece to many of the discoveries that you all have made, correct?
Yes, our threat hunting is based on two concepts. First one is filtering interesting behaviors, and the second one is predicted threat hunting models. So, which are again developed based on the observed behaviors. So,
Great. I think we can move to the next slide and we can talk a bit about just the general consequences, just the great impact that this compromise had. So just to make it clear, what is the current status of the extension? Obviously, it's not, like an NPM package that's malicious that gets removed from the repository altogether. It's still up on VS Code. So how does that work? What is the current status? And how did you all go about reporting the malicious behavior that you found?
Well, currently the extension is up, but let's talk about it a little bit more chronologically. When we first when we first found out this compromise, we contacted the VS Code Marketplace admins, and they took the whole extension down. And then a few days later, after they took it down, the 7Fini organization fixed the compromise, and a new clean version was then again published on the marketplace. And this all was in a matter of like 1 week, 2 weeks from the from our report to the takedown to the fix and the republishing of the package.
Gotcha. Yeah, and I know we already talked a bit about in past slides just, the full extent of the compromise and who exactly was impacted. But was there anything else that Pitar, Carlo, you just wanted to say in regards to what this means for developers at the moment?
Well, I think the biggest take you can get from this is like even trusted application extensions that you have can be compromised without you even knowing. As Carlos said, as soon as the users of this extension restarted their IDEs after the extension updated, boom, they were compromised just like that.
So again, and regarding the last question, other compromise, we can compare this one to during our threat hunting daily, we encountered, let's say, two types of compromises. First one is when malicious actors publish their own packages and try to lurk developers into installing their malicious packages. And the second type, which is of course more dangerous, is the compromise of legit extensions, packages, anything you wish, depending on the package repository. Like in this case, here you have a trusted base of user, and when somebody publishes an official new version that is compromised, the impact is bigger because you already have user base. It doesn't matter if it's okay. It does matter if it's 6,000 or 600,000, but the principle is the same. You have people that implicitly trust this extension, and all of them will be at greater risk than if developer needs to make them install the extension. What we can compromise, there was, I believe, a year or something like that, Ledger Connect Kit had a compromise of NPM package, and in that case, in just a matter of 1 or 2 hours, how long the malicious version was up, damage from around a few $100,000 were made in total. This last weekend, we had a compromise after a phishing campaign. Maintainer of the prettier ESLint prettier config prettier was compromised, and on their npm package again, malicious version of the package was published, and likely somebody was compromised. Again, you have a situation where people aren't including code. They are just using a configuration that is hosted as an npm package, and what they do, they download it, install it on their machine just so they could locally run tools like code formatters. That's not something that will end in production product, but you as developer will be damaged and your machine will get compromised, and that is open doorway to your entire organization. So this is impactful because official legitimate product was compromised. So that's always more dangerous and more impactful than when attackers develop their own packages. However, it doesn't matter how trustworthy they look, but they need to build a user base. In this case, you already have a user base that will get compromised.
Thank you. Yeah. And Carlo, you did hit on, that last question and regarding, like what can we compare this compromise to? And you pointed out, the two different types of compromises and this current compromise being, a more severe one. I know that in the blog post, Pitar, that you wrote for this compromise, which we'll share with you all, and I believe if you go to the resources tab at the bottom of your screen, you should be able to find it, and that includes, all the details for the compromise. But in that blog post, to give background, I know that it was mentioned that, the hacks of, really big name companies like SolarWinds Orion platform. I know that happened in 2020, a very big software supply chain attack that we call Sunburst, as well as, the 2023 incident affecting 3CX's desktop app. I know that those were referenced in your blog post as maybe being comparable to this specific compromise. Are you able to elaborate, Carlo or Pitar, more on that?
Yeah, these compromises and the compromise of like open source tools like the XZ utils are in basically they are similar in a way that the compromise happened due to a malicious threat actor pushing some new code that was masked as being good or helpful to the community. So for example, I think in XZ Utils, there was an account that was publishing goodware code for months, and then one day he just posted an obfuscated version of malware in a PR, and that was digested in the code base.
Very scary.
A similar, yeah, similar thing happened here, basically. The only difference here is that the account that made the pull request was created on the same day that the pull request was opened. So that's a big red flag.
Yeah. All right. Well, I guess with that, we can move to our next slide, which really this is, Carlo, Petar, your chance to just give, bottom line, what lessons should developers really be taking away from this compromise? I know you mentioned a few, regarding how this impacts just VS Code extensions in general and the security of them. But yeah, why don't you two just walk us through the bottom line here for developers?
So as I've said before, if you receive a pull request, it doesn't take much time and it can be very helpful to you to verify the identity and the history of the contributor. That means checking when the account was created, the activity on that GitHub account, to which other projects did you contribute and what did you contribute. Also, if you notice that a pull request introduced new dependencies, you should also check out and vet these dependencies yourself to make sure that they do not contain any malicious code. You can also use tools like RL Spectre Assure, which basically do most of the heavy lifting for you, such as tracking changes and vulnerabilities across software versions, giving you access to like common malicious behavior, and in general they give good insight over your software.
And conceptually, it's to keep in mind that it's not just packages containing code are the potential source of compromise. Extensions for your developer tools, configuration for your developer tools can often be abused to trigger installation of malicious software. So don't blindly think, okay, this is just an extension for my IDE, nothing can go wrong. This is just a browser extension, nothing can go wrong. This is the configuration, but okay, it's hosted on NPM. What could go wrong here? It's just a configuration. It's all those package repositories mostly include concept for automatic running of script upon package installation that can lead to code execution. So it's not just configuration, it's not just an extension, it's a way to execute code. Everything you install on your machine can be a source of compromise.
Yeah, like really going after, I think, and I don't know if there's anything else you want to add in response to this, but I think to me, just in seeing the discoveries that, our talented team, Carlo, Petar, and others here at Reversing Labs have made is, not just going after the packages, as Carlo said, but I think really going after developer infrastructure and, taking more sophisticated, using more sophisticated lengths to make these compromises happen, is very interesting. Do you all think that the threat landscape is moving more in this direction of sophistication and also just the targeting of, developer infrastructure, to really go after developers?
Well, I believe developers are the main target for at least 2 years now.
Yeah.
So it's not like it's moving, it's already here. It can only move away from that into something else. They are the main targets, especially ones using crypto assets and similar stuff that are developing for blockchain. if you manage to put your malicious code into some tool that will mainstream into blockchain community, you will have easy way to silently steal funds, crypto funds.
Right. I think one of our favorite lines here at Reversing Labs is robbers rob banks because that's where the money is. So applicable to, yeah, all the crypto stuff as well, with developers especially. So I guess we can go on to our next slide. So we're actually going to hop into a demo and I'm going to pass it over to Carlo to show us Spectra Assure Community, which is Reversing Labs open source platform. And we recently added a feature to the community that allows folks to vet VS Code extensions. So I'll give it away to Carlo, but before I do that, I did just want to remind you all that if you do have any questions, now is a great time to submit those to the Q&A feature or throw them in the chat. Once Carlo finishes up the demonstration here, we'll be going through those questions, so please ask them away. So I'll turn it over to Carlo.
You are muted.
Myself. Okay, this is our secure software web page. Even you can, this is a free tool. You can use it to vet your dependencies and look for issues related to the software packages you plan to use. In this case, we have, well, tool like tool, we have navigation where you can search for packages by their name or hashes and look what is found and how the general display about extension packages, whatever you want to search for is you have here up you have like a summary of the findings in the package related to tampering and malware. This is likely the most interesting for most users, but also hardening, known vulnerability detected inside the package, secrets that your software leaks or are leaked by third-party software, and license issues. So those are 6 key fields that we cover with our product. And up here you have basic information about the product, the latest version, the popularity of the product, the name of the product, links to the repository and the marketplace for, as stated on the marketplace, so that this data that is just duplicated and put here, so you could quickly navigate things that you'd always find in the marketplace of package explorer. And the interesting things are also collection of versions and definitely the issues found in the software package you are examining. So here down you have top 5 issues related to the extensions we are looking at, and here you can see that this latest version is clean, but it has some threat hunting issues that could be a reason for you to take a detailed examination of the version you are planning to use in your project. But also you can see all the latest versions, and in this way you can find out which were malicious or removed from the marketplace. Here you can see that previous version 0.50 is the one we detected. And if you take a more detailed look here, you can see when it was reported by our researchers. And down here, you can see the issues that were found. Here we have one of the most notable things that that fall into the eye is the detected presence of files with behavior similar to malicious and packages published on NPM. So this is the warning triggering about ML detection of predictive threat hunting model. And such warning is a red flag for you to examine and should, okay, ML models can have false positives, but if you're not in a hurry, double check it and make sure that that is truly a false positive, not a true positive. Also, you have behaviors. You can list all the behaviors that were found inside the package, and that can lead also to conclusion that something is off. Okay, if you compare the latest version and previous version, you can see that in the, okay, sorry, I'm looking at 1.0.0. You can clearly see the presence of potential obfuscate folder data that is not seen in newer or older versions of this extension. So you have something that is obfuscated, you should double check it. And there are various other behaviors that can lead you into sense of insecurity related to this package. Again, it's easy to spot if something is malicious or not. You just visit it here, you will have signs that it is malicious. Threats will be noted, malware and tampering, and also you will see some timeline when this occurred and who has discovered it, so you could quickly search more about the reason of the compromise. That's basically everything that is to be said. You can look at dependencies of your project if you, or of a project you are planning to use, to see if it has something clearly malicious here. Also, it won't be flagged, but if you know that something is malicious, like Ethereum utils, you will perhaps be able to find it. Here you can see that this was also malicious.
Thanks, Carl.
For automated detection of malicious dependencies, you need to use paid version of the tool. So, but you have enough information for basic vetting of tools you plan to use.
Carlo, I was just going to ask before you close out, do you mind going up to the search bar and just kind of going to that toggle? That way we can just show folks, you know, really like it's not just NPM and VS Code that you have support for here with Spectre Shirt Community. It's all these other open source platforms that developers rely on. So you can scan modules for any of these repositories and platforms.
Yeah, and also on the home page you can find more info. You have access to communities. You can look and find popular NPM packages. So let's say you want top 100 packages on NPM to be showed. You can see what are the most popular packages and quickly find if something you're planning to use. If you're searching for something, you can find it here also. Popularity is one way to say something is more secure to use than other, but again, as we said, legit extensions and packages get compromised also. You can also look at the blogs. We have recently shared our threat research blogs, where you can find all kinds of threats that we discovered in history, and you can also see the recent threat research packages that our threat researchers found, and these were malicious in the package repositories from your choice. So there is a lot of info on this page that you can explore and find out for packages like PyPI, NPM, Ruby Gems, NuGet, and now freshly supported VS Code extensions.
Great. Thank you so much, Carlo. I think we can go back to the slides now. So just before we wrap things up here, just wanted to again give a shout out if there are any questions from everybody attending today. This is your time to ask them. Carlo and Petar can go ahead and share their insightful answers for you. I did have one question that I realized we didn't really chat too much about earlier, which is, what do we know about the threat actor who, you know, submitted the pull request for this extension? I believe the name of the threat actor is Erez299. Is there anything we know about this user and, you know, who they are and what happened here?
No, the account was a throwaway account. It was created the same day as the pull request, and it has no previous activity, so we don't really know much about it.
Gotcha. So while I wait for any other questions here, I did want to highlight just additional resources that we have for you all before we close out. So if you go to the bottom of your screen, you should be able to see the resources tab, and all of these are linked. We have the blog post that Pitar wrote about the compromise that includes all the details and more that we talked about today. There's also a great blog post talking a little bit more about how developers can use Spectre Assure Community, which Carlo just showed you to vet VS Code extensions. And then lastly, of course, we have linked Spectre Assure Community for you all to bookmark and flag and really take a look at and use as a resource going forward. So I think given the fact that we don't have any other questions, I'll just go ahead and highlight some upcoming events that Reversing Labs has that you should definitely check out if you're interested. We've got a great webinar happening tomorrow about how to get software vendors to fix their code. So really thinking if you work with a third-party software provider and you want them to take better ownership over their code, you should definitely check out this webinar to make sure that you can feel empowered to do that as an organization. Happening next week, we have a conversation about Verizon's data breach investigations report that came out this year and talking about the impact of third-party risk. So that should be a great conversation. And then we also have another webinar happening where we'll be diving into Spectre Detect, which is one of Reversing Labs solutions, and really diving into the new features that just came out for that solution. But overall, I think it's safe to say that we are all set for today. Carlo, Pitar, is there anything else that we didn't cover that you wanted to share before we close out?
Nothing from my side.
Great.
I think also we pretty much covered everything.
Wonderful. Awesome. Well, we thank you all so much for joining us today for this webinar. If you want to stay connected with us, we encourage you to follow us on X, formerly Twitter. We've got a LinkedIn, we've got a YouTube account. We do a really good job of posting to our X about any new compromises that our team has discovered, providing our analysis. So it's a great way to keep up with the great work that Carlo, Pitar, and the other threat researchers here at Reversing Labs are doing. So with that, I believe we are all set for today. Thank you so much for joining us, and we hope to see you next time. Thank you. Have a great day, everybody.